Divisibility. Here we will be using the sutras Vilokanam by observation and Antyayorewa by the last digits. We'll start with odd and even. Whole numbers are either odd or even. Even numbers can be divided into two equal numbers. For example, 12 is 6 add 6. But odd numbers cannot be divided into two equal numbers. For example, 13 is 6 add 7. Even numbers always end with an even digit. Divisibility by 4. When any number is multiplied by 4, the last two digits form a number that is divisible by 4. For example, 1293 times 4 is 5172. And 72 divided by 4 is 18. And so 72 is divisible by 4. If the last two digits are divisible by 4, then so is the whole number. Which of these are divisible by 4? Stop the video and work through these. Okay, now I'll show you the answers. Divisibility by 2, 4, 8, 16. For divisibility checks for 2, 4, 8 and 16 and higher powers of 2, we inspect the last digits as follows. For divisibility by 2, we look at the last digit. If it's divisible by 2, then the whole number is. For 4, we look at the last two digits, and if divisible by 4, then the whole number is. For 8, we look at the last three digits, and if that number is divisible by 8, then so is the whole number. Similarly, for 16, we look at the last four digits. Work through this exercise to find out which of these numbers are divisible by 2, 4, 8 and 16. Okay, now I will show you the answers. Divisibility by 9. A number is divisible by 9 if the digital root is 9. Here is an example, 70,821. If we add the digits, we get 18, and then add 1 and 8 is 9. And so the digital root of this number is 9, and so it is divisible by 9. We can also find the digital root by casting out 9s. 7 and 2 add to 9. 8 and 1 add to 9. And so we are left with nothing, and that means the digital root is 9. Work through this exercise by looking at the digital roots to find out which are divisible by 9. Okay, now I'll show the answers. Divisibility by 3. A number is divisible by 3 if the digital root is 3, 6 or 9. For example, 735. Add the digits, we get 15. Add 1 and 5 to get 6. So 6 is the digital root, and so 735 is divisible by 3. Let's look at 736. The digital root is 7. And 736 divided by 3, sure enough, it leaves a remainder of 1. Let's have a look at 737. The digital root is 8. And this number divided by 3 is 245, remainder 2. 738 has a digital root of 9. And on dividing by 3, it leads to 246. Find the digital root to see which of the following are divisible by 3. Okay, I'll show the answers now. Here are the digital roots, and so these ones are divisible or not. Moving on to compound numbers 5, 6, 12, 15 and 18, we can combine the previous rules. A number is divisible by 5 if it ends with 5 or 0, 6 if it is divisible by both 2 and 3, 12 if it is divisible by both 4 and 3, 15 if it is divisible by both 3 and 5, and 18 if it is divisible by both 2 and 9. Work through this exercise to find out which are divisible by 3, 4, 5, 6, 9, 12, 15 and 18. Okay, so here are the answers. So this gives an introduction to simple divisibility.